Miss Collier explains
angles at a point.
Our learning intentions are to know the meaning of the terms adjacent, complementary, supplementary, vertically opposite, and perpendicular, and to be able to find angles at a point using angle sums of 90, 180, and 360 degrees.
We will know we are successful when we can find the size of angles without a protractor using other angles around a point. P.S. How did I forget to film the success criteria? Oops.
So let's find angles at a point. Now I'm going to tell you that this is actually some of my favorite maths because it's what I call easy maths. It's actually not that complicated. All you have to do is learn the rules and then it's not really that much math involved. So angles are everywhere in everyday life, okay? People who calculate angles formed by intersecting lines can include glass cutters. They have to design and construct stained glass windows. It also includes jewelers. They would have to use it to cut gemstones at precise angles to fit into their jewelry. And even quilt makers who design and sew different geometric shapes in with each other. They would all be using angles formed by intersecting lines. If I have a diagram with intersecting lines on it, that would form angles. Now to find the size of these angles, I don't always need a protractor. Some of them I can actually mathematically figure out what the size of the angles is. That's because there's actual special relationships that are formed when lines intersect each other, and there's laws about what the size of the angles between them are. These rules are actually extremely important to us and can be very helpful when diagrams are not drawn to scale, and that's something I'm always going to warn you about. Whenever you see a diagram and you can see angles and things like that on it, never trust your eyes. Okay, that's what I'm going to say to you. Sometimes you can even have an angle that's this big and it says 40 degrees and you're like, it can't be 40 degrees because that's not an acute angle. But in mathematics, we always trust the information that's being given to us on the diagram over what our eyes say, because sometimes diagrams aren't drawn to scale. Obviously, you hope the mathematician that drew you the diagram is going to take some time to make it look a bit realistic. But when we've got diagrams that aren't drawn to scale, we might not be able to use a protractor to figure out the size of the angles anyway. Let's go over some of the key language that I might use now so that you know what I'm talking about. We have what we call a vertex. So a vertex is a point where two or more lines meet. So here are my lines and they're meeting. This little red dot here is called a vertex because that's where two or more lines have met together. Then we call these arms. Okay, these are the arms of an angle. We call arms adjacent if they are right next to each other. So in my diagram here, the line OB, which is this one, and the line OC are adjacent to each other because they are next to each other. The last thing that you need to know is that sometimes when we don't know a number, we can replace it with a symbol or with a letter, which we call pronumeral, to say we're not sure about what this is yet, we're going to find out how big it is. So right now we're going to learn 5 rules. Once we know the 5 rules, we can basically figure out angles for lines that meet at a point. So the first rule is called complementary angles. And complementary angles are angles that add up to 90 degrees. So looking at my diagram here, I have a 90-degree angle. It comes down here and across here. And the reason I know it's 90 degrees is because of the little square symbol in the corner. Now, anywhere I pop a line in between those, the two angles are always going to add to 90. So for example here, I've got an angle of 60 and an angle of 30. They add up to 90 because they are within right angles. So rule number 1, two angles inside of a 90-degree angle are complementary and they will always add to 90 degrees. Next we have supplementary angles. These are angles that add to 180. So I can see I have a straight line and I know that a straight line is 180 degrees. And so any angles that are joined together to create a straight line, they are going to add to 180. My example here, I have an angle of 60 and an angle of 120. So rule number 2, if I have a straight line, the two angles that form that straight line are supplementary angles and will always add to 180. Next we have angles in a revolution. These can also be called angles around a point. That's because I've got my one point there, my vertex, and these angles go all the way around. I know that all the way round in angle talk is 360 degrees. So the angles in a revolution will always add up to 360 degrees. In my example, I have 5 angles, 120, 60, 45, 35, and 100. But adding them all up, they will always add 360. So rule number 3, if I have a point and I have lines coming out of it, the angles that are formed around there will always add up to 360 because they are angles at a revolution. Okay, now, this is probably one of my favorite, vertically opposite angles. If I have 2 straight lines that intersect each other, they will create the same size angle on the opposite side. So we call them vertically opposite because they're opposite each other on the x. They will always be the same size. So it's always good to look for the symbol x, and we will use the symbol x when we show our working out. But you can see here on this x, these 2 angles are 75 and these 2 angles are 105. When they're opposite each other, they will always be exactly the same. So rule number 4 is vertically opposite angles are always the same size. And lastly, we have perpendicular lines. If you've never heard of the word perpendicular, it means that 2 lines cross at exactly right angles, making a perfect X. This is the symbol that we give to perpendicular lines. When this happens, we have created 4 90-degree angles, and they will be 90 degrees all the way round. So rule number 5, perpendicular lines always create 4 90-degree angles. Now that we know these rules, let's have a go at using them to create some quick math. Let's find angles at a point. Without using a protractor, find the value of the pronumeral a. So there's that pronumeral I was talking about, and anytime we don't know the size, they've just put the letter a, and that's the size we're trying to look for. So let's go. Question A. Okay, now I've got an angle that is at a right angle. My right angle was my complementary angles. Now to show our working out, what we like to do is we draw the right-hand symbol and we do a line. That is showing that we know the complementary angle rule and that it's the right-hand rule. It's always a good idea to put your little right-hand symbol in there. So my right-hand rule says that my 2 numbers will add to 90. So my 2 numbers here are a plus 35, and they add up to equal 90. Okay, now I've got a plus 35 equals 90. Now we know the opposite of plus is minus, so I'm going to go a equals 90 take away 35. If I take away the 35 from the 90, it'll show me how much is left over for the a. And that is 55. Now I must remember my little degrees symbol, and the size a is 55. I always like to do a quick check. 55 plus 35, that's 90. That's my complementary angle. B I can see is a straight line. That was my supplementary angle. So I'm going to draw my symbol for a supplementary angle, which is a straight line and a little up. I know that supplementary angles add to 180. So what do I have? I've got a plus 55 equals 180. So again, I need to take away that 55 to see how much is left. A equals 180 take 55. If I do that in my head, I'm going to end up with 125, and I must do the little degrees symbol. So that angle is 125. And lastly, I have C, which is angles around a point. This symbol, I like to do 3 lines in random directions and then a circle. This is to tell me that all of my angles should add up to 360 degrees. So I've got A, and then I've got 120, and then I've got this angle that doesn't tell me the size, but it's got the square which tells me it's 90 degrees. So plus 90 equals, they all add up to 360. What I would do first is do that addition. So A plus 120 plus 90 equals 210. Now I'm going to take away the 210 to see how much is left for my A. A equals 360 take away 210. So I have 150 degrees left for my A. So my A is 150 degrees. I hope you can see that it's not very hard mathematics, but it's just about remembering which rule applies for which situation. You have a go at trying to do some of these angles around a point. Let's check your answers. A. A is a right angle, so therefore I'm doing a right angle symbol for my complementary angle. A plus 65 equals 90. A equals 90, take away the 65. A equals 25 degrees. B. B is on a straight line. Straight line is 180 degrees. So A plus 130 equals 180 degrees. A equals 180, take away the 130 to see how much is left. A equals 50 degrees. And lastly, I have C, which is angles around a point. Angles around a point equal 360. So A plus 50 plus 90, there's a 90 in there, equals 360. A plus 140 equals 360. A equals 360, take away what we've used up on the 140, and so A is 220 degrees because that's how much I had left over. I hope now you can see that you can find the size of angles without a protractor by using the other angles around the point. It's a good idea to stop and try and memorize these rules.